Pluto is orbiting what we call the Kuiper belt, where thousands of other objects are also orbiting out there with Pluto. This is largely a great world, just like the asteroid belt. Correct? NASA on their pioneering decade-long mission to explore. The Pluto system and the Kuiper belt, billions of miles from Earth, has sent a little robotic spacecraft to show us the first glimpse of mysterious Pluto, the distant icy world at the very end of our solar system. Pluto is orbiting what we call the Kuiper belt, and there are thousands of other objects orbiting out there with Pluto. This is a littered, great world, just like the asteroid belt. Correct. At first, Pluto seemed like just another frozen, forgotten rock, a distant relic at the edge of our solar system. But the truth is far more extraordinary than anyone ever imagined. What if I told you that beneath Pluto's icy, desolate surface, there's something hiding, a secret so huge it could change everything we thought we knew about the cosmos? Imagine the shock when scientists discovered that Pluto isn't lifeless after all. It has an underground volcanic ocean and even the building blocks of life hidden from us all this time. What could this mean for the search for life beyond Earth? Could the cold, distant world of Pluto hold the key to understanding life in the most unexpected places? Get ready, because what's been hiding on Pluto for all these years will blow your mind. Pluto for years was considered a desolate, frozen world on the fringe of our solar system. It seemed like a place too distant and too cold to have any significant features, much less something as unexpected as life. But that perception is quickly changing, thanks to groundbreaking discoveries made by the James Webb Space Telescope. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. At first, some scientists were puzzled by unusual data, a signal that hinted at something much more than a frozen shell. As the telescope turned its infrared lenses toward Pluto, it revealed something incredible: an underground ocean. This is a game changer for a planet so far from the sun and with surface temperatures that can dip as low as 375 degrees. How could water stay liquid? The answer lies in something surprising: Pluto's interaction with its moon, Charon. Through a process known as tidal heating, the gravitational pull between Pluto and Charon generates enough internal heat to keep Pluto's subsurface ocean from freezing solid, a hidden liquid ocean beneath a frozen surface, something we never expected to find on a planet so distant. But wait, there's more. The James Webb Space Telescope didn't stop there. As it examined Pluto's atmosphere, scientists were stunned to find organic molecules, the building blocks of life. Organic compounds aren't just signs of chemical processes. They're the very ingredients that could form life itself. Imagine this: Pluto, once considered a lifeless ice ball, might actually be hiding some of the most fundamental elements needed for life. These organic molecules suggest that Pluto's atmosphere could be undergoing complex chemical reactions, much like those that occur on Earth, possibly opening the door to the unimaginable: life on Pluto, or at least the potential for it. This is a possibility that has scientists buzzing, making us rethink what makes a planet habitable. The more we learn, the more we realize Pluto isn't the frozen wasteland we once thought it was. It's a dynamic world with secrets hidden beneath its icy shell, secrets that could change our entire understanding of life beyond Earth. These discoveries aren't just interesting, they're game-changing. For years, we believed life had to depend on the warmth of the sun. After all, here on Earth, the sun fuels everything. But what if life could survive without sunlight? What if it could thrive in places so distant and cold that the sun is just a faint dot in the sky? This idea isn't as far-fetched as it sounds. On Earth, in the deepest parts of the ocean, there are entire ecosystems living in complete darkness. These environments are far from the sun, yet life not only survives, it flourishes. And this is exactly the kind of environment that Pluto may offer beneath its icy surface. Pluto, we now know, is not the cold, lifeless world we once thought it was. It has a hidden subsurface ocean, kept liquid by a process called tidal heating. This is where Pluto gets its energy, through a gravitational interaction with its moon, Charon. As Pluto and Charon dance around each other, they pull and stretch, creating friction that generates heat inside Pluto. This heat is enough to keep its underground ocean from freezing solid despite the frigid surface temperatures. The James Webb Space Telescope also detected organic molecules in Pluto's atmosphere, building blocks of life, the same compounds found in environments on Earth rich in life. The presence of these molecules raises an important question: could there be life, even microbial, thriving in that ocean? While we don't have definitive proof yet, the conditions needed for life, organic chemistry, water, and heat, are all there. Of course, many wonder if Pluto has oxygen. It doesn't. Its atmosphere is mostly nitrogen, with traces of methane and carbon monoxide. But life on Earth has evolved in extreme conditions where oxygen isn't present. The same might be true for potential life on Pluto. So how powerful is Pluto? It might not have the size or mass of a planet like Earth, but in its own way, Pluto is incredibly powerful. It's not just an icy rock at the edge of the solar system. Pluto is alive with potential. Hidden beneath its surface, there's an ocean, a dynamic atmosphere, and evidence of complex geological activity like cryovolcanism. This tells us that Pluto isn't as dead as we thought. Its geological processes could sustain a hidden world beneath. These findings are forcing us to rethink what we know about the habitability of distant worlds. If Pluto, once thought to be a desolate ice ball, can support conditions needed for life, then what else might be out there in the far reaches of space? The main challenge in exploring Pluto was accessing meaningful data from such a distant and isolated world. At nearly 4.7 billion miles from Earth, Pluto was a target too far for traditional methods of space exploration. The extreme cold and lack of sunlight made it impossible to study with conventional telescopes, limiting our understanding to only surface-level observations. But thanks to advancements in technology and missions like New Horizons and the James Webb Space Telescope, our understanding of Pluto has undergone a revolution. New Horizons gave us our first close-up views of Pluto's surface, revealing a surprisingly dynamic and complex world. But it was the James Webb Space Telescope that allowed us to peer deeper, uncovering the mysteries beneath Pluto's icy shell. Webb's incredible infrared capabilities provided a breakthrough, revealing organic molecules and tidal heating clues to Pluto's hidden potential. This wasn't just a discovery about Pluto. It opened new doors in the search for life across the cosmos. If a small, distant world like Pluto can have the ingredients for life, what about other icy moons or exoplanets orbiting far from their stars? Could Europa or Enceladus, moons in our own solar system with subsurface oceans, also harbor life? And what about planets orbiting dim red dwarf stars where warmth from the sun is limited? Could they harbor life? The discoveries on Pluto have redefined the boundaries of what we consider habitable. Scientists now believe that life doesn't need a sun to thrive. It needs energy, water, and the right chemistry. These conditions could exist in countless places across the universe, from icy moons to rogue planets floating freely in space. The implications are staggering. If life can exist in such extreme and unexpected environments, then the universe could be teeming with it. Microbial life may thrive in the dark oceans of distant worlds, while more complex organisms could evolve in ways we can't even begin to imagine. Exploring Pluto is just the beginning. It's a reminder of how little we know and how much there is yet to discover. Missions to explore the outer solar system and beyond will help answer some of the biggest questions humanity has ever asked. Are we alone, or is life an inevitable outcome of the universe's processes?